Hi, I'm Chris Andrews, COO and Head of Product at Rendered.ai. I am going to recap a quick chat that I gave at the Edge Computing World event in Santa Clara this week. My background is in both product development and enterprise consulting, primarily focused on the geospatial market, especially around 3D applications in the defense, AEC CAD BIM, and related areas. I also spent a little bit of time in film and game, and then I even ran a startup effort in molecular visualization while I was at Autodesk. I'm really excited to be with Rendered.ai now and able to bring together my background in simulation, 3D, and making hard problems easier for users in Rendered.ai. Rendered.ai offers a platform as a service for computer vision customers who are struggling with the cost and challenge of acquiring or using real sensor data for training and validating computer vision and machine vision systems. Rendered was established in 2019 in Bellevue. We work through a subscription model. That's our primary business model, in which either you can use the pass on your own or we can actually help you. And then what we see is customers come to us because we tend to be the fastest path to setup and configuration for synthetic data generation for a wide variety of applications, including some of the applications shown on the right. Customers work with Rendered to produce fully labeled computer vision data in a variety of spaces, including both visible and non-visible spectra. And you can see we have experience with remote sensing, toys and bins, X-ray, and many other sensor domains and problem sets. One of the takeaway messages from all of our conversations with customers is that AI always changes. The problems that your AI solves this year will not be the problems you need solved next year. On top of that, your AI is only as good as the data that you have to train it. Most of our customers, all of our customers, are coming to us struggling with the problem of acquiring real-world data to train AI. Real-world data can be costly and time-intensive to acquire. All data sets have bias, but real sensor data sets definitely have bias in the sense that you can only train for what you can capture. In the case of some customers who want to have data sets for digital twins or future sensor systems that don't yet exist, they're unable to innovate simply because they cannot acquire real sensor data. And of course, most of our customers rely on human or automated labeling processes, which tend to be imprecise and incomplete. And in the case of things like X-ray or SAR or other non-visible spectra, humans are pretty bad at labeling some of those. So in those cases, accuracy can be even lower. A stat that I heard recently is that 85% of data is unstructured, unlabeled, and not ready for AI. Most of our customers work with computer vision content, such as imagery, video, or even point clouds, all of which falls in the category of unstructured data. What we heard at the Edge World Computing Conference is that the challenges of using AI at the edge tend to be very similar to the challenges of the AI market at large, except possibly a little bit more acute. At the edge, innovators and customers are attempting to rapidly process information being sensed remotely. However, they run into issues of cost, accuracy, privacy and security, and time to market. All of that is compounded by the fact that the edge, if anything, is even more dependent upon unstructured data. Synthetic data has the potential to solve the AI data problem. Synthetic data is engineered or intentionally designed data that AI is able to interpret as if it is real data. So what we offer is a pass and developer framework and a support system for customers who want to generate synthetic computer vision data to solve their AI problems. We already have customers who are using AI at the edge, and synthetic data is helping them to move faster and to be more effective. For example, customers may be using AI to do things like train onboard or fixed mount imagery and video detection systems where they train in the cloud and then deploy just the AI trained parameters to the edge units. We also have customers who are looking at using synthetic data to train onboard satellite detection systems so that the satellite can detect objects, instances, or even classify areas and only send down to Earth the information that is needed and not every pixel that's being collected. And of course, we have customers who are in the machine vision and computer vision detection space who are using AI to detect things like point of sale applications, counting things, and many common retail type computer vision applications. All of the images that you've seen in this presentation are examples of physics-based simulated synthetic data sets that are used to augment or replace real data sets for purposes of training AI. And as you can see, this is possible across a wide variety of domains. Today's AI workflow essentially focuses on acquiring or collecting real-world data, training on the real-world data, getting whatever you get, maybe modifying the training data set a little bit to try to optimize algorithm performance trained on it, and then using what you've got. So you're kind of stuck with what you started with in terms of data. Tomorrow's AI workflow incorporates synthetic data such that you can intentionally create the data that you think will work for your particular business problem. You can train, test, and then even compare data sets or even compare, modify and compare data sets such that if you're not happy with the results, you can then create more data and go back into this iterative process. So synthetic data tends to be inexpensive, unlimited, and can be generated on demand. Synthetic data is 100% accurate. In our case, we are using 3D model simulations with physics-based rendered output, and we know what is in the simulated 3D scenario. Therefore, the labeling of the content in that scenario is 100% accurate. Real data sets can still be used in synthetic data workflows, both for comparison and post-processing of synthetic data. And synthetic data sets can be designed for edge or impossible cases and to remove bias from a training data set. So how does it work? Hypothetically, many customers actually jump in and try this. The ideal workflow that many customers think of is that they will engage a simulator in some way, maybe have an internal dev team work with a game engine, generate a data set, and then train a bunch of AI models. And what we've seen is that this never actually works. Synthetic data requires an iterative workflow that typically starts out with someone who we call a synthetic data engineer, who will basically construct a world, the world of simulation possibilities for the data set that they'd like to create. They will also configure a simulator that can be deployed, in our case, to the Rendered.ai platform, where our managed compute can be used to configure the data generation and to generate many data sets. These data sets then can be analyzed by a data scientist using some of our tools and other industry standard tools, both for things like post-processing, but also for quality assessment and for AI model training. Depending upon the results of training and assessment, the data scientist then may want to feed some requirements back to the synthetic data engineer, who can update the simulation and then allow the data scientist to actually generate more modified data using the Rendered.ai platform. This is the iterative pattern that tends to work in real world cases where we've seen our customers be highly successful with synthetic data. Our solution has two major components. What tends to be most visible to folks is the output imagery that we create. And so what you're seeing in this entire presentation is synthetic simulated imagery. And so we have a variety of custom and pre-configured vertical applications and scenarios that are available for customers who are working in close domains to those to get started quickly. Of course, for customers who are working in new domains to us, we can help them get started. Underneath pre-configured examples are repeatable tools and workflows on top of our platform as a service for turning these simulated scenarios and output into insights and outcomes. Underneath it all then, we also have a Python SDK and web app access both. The Python SDK allows our customers to integrate synthetic data generation in a headless manner into enterprise AI pipelines. All right, so thank you very much for giving me a little bit of time today. You can find out more about us at www.rendered.ai. You can also follow us on Twitter and LinkedIn, and we have a blog on Medium. And then if you are an AWS enterprise buyer, you can actually find us on the AWS Marketplace. Thank you.